For this circuit I need to find the power dissipated by this 8 ohms resistance, and I will use source conversion techniques to do that. So what I will do first, I will convert this current source and the parallel resistance into a voltage source and a series resistance. So the direction of the current source here is upwards, so the voltage source polarity will be plus minus like that, and the 10 ohms will come in series, and that's the 8 ohms resistance there, and here is the 6 ohms. Now about value of the voltage source will be 10 times 3, so that will be 30 volts, just the resistance times the current there, so that's there. Now in this part we have a voltage source and a series resistance. I will convert it into a current source and a parallel resistance. So the resistance will come in parallel with the current source, and the current source polarity will be, since the voltage source is plus here minus in here, the current driven is upwards by the voltage source, so the current source direction will be also upwards, the arrow will be upwards, and the value will be 15 divided by 3 here, so that will be 5 amps. So that's there. Now this part we won't change anything, we will just leave it like that, and we can't we have to leave this 8 ohms as it is. We can't add it with the 10 ohms there, because it is the power dissipated by the 8 ohms, that's what we need to find out. So we can't we have to leave it like that. Now these two are coming in parallel, so I will find the equivalent parallel resistance, and that will be, so here this is the value of the voltage source, which is 30 volts, then 10 ohms and 8 ohms like that, 8 ohms, and here the parallel combination of 6 and 3 is 6 times 3 over 6 plus 3, that is 18 over 9, which is 2, so that's 2 ohms there, and the current source value is 5 amps, so that's there. Now this part I will convert it into a voltage source and a series resistance. So then we will just have a series circuit, a simple series circuit with 2 voltage sources and 3 resistances. So that will be very simple to solve. So this one, when we convert this one, the resistance will come in series 2 ohms, and the value of the voltage source, the polarity will be plus here minus here, because the current was upwards, the direction of the current source. So the value will be 5 times 2, that is 10 volts there. So we have like that. Now we know that the polarity of the voltage source, this one drives current in this direction, this one in the other direction, so the resultant will be 30 minus 20. So if we look at the current here, I, which is, this is a simple series circuit, so there will be just one current, and the resultant voltage EMF, driving voltage or resultant voltage of the voltage source, is 30 minus 10, which is 20, so that's there, V, and the summation of current is summation of resistance is 10 plus 8 plus 2, that is 20 as well. So the current is becoming 1 ampere. So that's the current. But now we need to find the power dissipated by the 8 ohms resistance, so that will be I square R. I square is 1 square and R is 8, so the result is 8 watt. 8 watts is the amount of power dissipated by the 8 ohms resistance.